This is part 2 of our lesson on simple machines. Today we're going to be focusing on non-movable machines. So we'll be looking at inclined planes, screw, and also a wedge. Okay, so our first non-movable simple machine that we're going to look at are inclined planes. Inclined planes are flat surfaces that are higher on one end. And even though they don't move, they make work easier by increasing the distance. Think about it this way. It's a lot easier to move something up a gradual ascent than it is to lift it straight up. All right, but keep in mind the trade-off of this is that the object has to be moved a longer distance than if it was lifted straight up. All right, on the positive side of that, you're using less force to be able to move it. It's just going over a longer distance. So some examples of inclined planes, of course, the stairs, a ramp. One that you may not have realized is an inclined plane is your bathtub. Okay. Finding the mechanical advantage or calculating the mechanical advantage on an inclined plane. These are relatively basic formulas here. So you take the length of the plane and divide that by the height of the plane. So you can see here in the example, this inclined plane has a length of 15 feet. It has a height of 3 feet. So if we divide that length divided by the height, 15 divided by 3, then that gives us a mechanical advantage of 5 for this particular inclined plane. All right, our next simple machine is a screw. So you probably don't know this, but a screw is an inclined plane that is rotated around a cylinder. Okay, actually I want to show you guys an example of this in class so you can actually visually see what it is I'm talking about with that. But anyway, a couple of terms you need to know about a screw is you have what's called the spirals. These are simply these threads that you would see. Sorry, let me turn my laser pointer on. Okay, spirals are these little threads here that you see. And then you've also got what's called the pitch. The pitch is simply the distance between those threads. So you have a pitch here, here's a pitch between these two here, okay? All right, so this is, this actually has a picture here of what I was talking about I wanted to show you guys in class. If you take a piece of paper, and like I said, I'll still do this in class so you can see it, but take a piece of paper, cut it out in this kind of triangular form here, like this inclined plane, and you take a pencil, so a pencil is a cylinder, and you wrap the inclined plane, that paper, around the cylinder, which it ends up looking like this or something like this. That's how you end up with a screw. Okay. As far as calculating the mechanical advantage, we don't really have a formula that we're using to calculate that. All you really have to look at is the pitch. Okay, so that distance between those threads there. When you have a smaller pitch, or the smaller the pitch is, the greater the mechanical advantage is going to be. Also, as far as a screw goes, you're not limited to an actual screw. It could also be like the top to a jar, okay, or a drill bit. Drill bit's a little bit more obvious, but the top to a some sort of jar of peanut butter, jar of jelly, whatever. That's an example of a screw as well. Okay, our last non-movable simple machine we're going to talk about is a wedge. So a wedge is simply, if you take two inclined planes and you join them together back to back, you're going to end up with a wedge. And we use wedges to split things. So examples, obviously an axe would be a good example of a wedge. Knives are also an example of a wedge. And also the zipper on your jacket, on your pants, whatever. That acts as a wedge as well. Remember, wedges, they split things. This is separating those teeth in the in that zipper. So there are two different parts, or two parts to a wedge that you need to be familiar with. You have what's called the you have the tapered edge, which acts as the resistance. So where it gets thinner here at this point, this is going to be that tapered edge. That is where the resistance is. And then this thicker edge up here at the top, that's where the force the work is going to go into this. This is where the effort is going to go. So as far as identifying the mechanical advantage of a wedge, we're not really having to calculate anything here. We could, I don't think we're going to have to, we don't have a formula that we're going to have to use for this class. Basically, when you're looking at which object has a higher mechanical advantage, then what you're going to be looking at is the tapered edge. If it has a sharper tapered edge to it, then it's going to have a higher mechanical advantage. Think of it in terms of these knives down here. You've got a steak knife versus a butter knife. This butter knife is going to be much thicker. Actually, think about if you were trying to cut a steak, obviously using the steak knife is going to be a whole lot easier. So as far as which one's going to have a higher mechanical advantage, it's definitely going to be that steak knife, okay? Now we can actually take these simple machines and we can put them together with other simple machines, and they form compound machines. Compound machines, it just means we've got two or more simple machines they're going to be working together. Now, of course, when you add more machines to it, have more than one simple machine working together, then that's going to increase your mechanical advantage of the machine as a whole. So if you recall, we mentioned early on when we were talking about levers, we said that scissors were an example of a lever. More specifically, there were examples that we provided for a first class lever. You can see here how this is labeled, the handle here acting as a lever. You have a fulcrum here, this other handle acting as a lever. But you can also see that the scissors, you have these two wedges here as well. Okay, so scissors would also be an example of a compound machine. So a bicycle is another great example of a compound machine. Here's just a few of the simple machines that you would find. This is not everything, but just to kind of get you started thinking about this, obviously you'd have screws that are holding the pieces of the bike together. You've got the wheel of the bicycle, that's a wheel and axle. The pedals are attached to a lever, that's turning a pulley. And also you've got gear shifts and brake handles that are acting as levers as well. So this wraps up our lesson on simple machines.